Just a few months ago, astronomers spotted something extraordinary, a brand new interstellar visitor called Comet 3I/Atlas. At first, it was just a dim blur with a strange path across the sky, and all anyone knew was that it came from beyond our solar system. But since then, things have taken a dramatic turn. The comet has brightened, its tail has exploded in size, and the James Webb Space Telescope has finally zoomed in for a closer look. What Webb uncovered left scientists stunned, a bizarre chemical makeup unlike anything ever seen before. It's so unusual that it's forcing astronomers to rethink what they thought they knew about how comets form and evolve. So, what exactly is going on with 3I/Atlas? Why is it so different? And what makes it one of the strangest cosmic visitors in human history? Let's rewind for a second. If you're hearing about 3I/Atlas for the first time, here's why it's such a big deal. In early July 2025, the Atlas survey in Chile detected a mysterious object gliding through the night sky. At first, it looked like any ordinary comet, faint, fuzzy, and quiet. But then, astronomers noticed something that didn't fit. Its orbit wasn't elliptical like comets that circle the sun. It was hyperbolic, meaning it wasn't coming back. In simpler terms, this object isn't from here. It's traveling so fast that the sun's gravity can't hold it, cutting through our solar system on a one-way journey from another star. And that's incredibly rare. In fact, humanity has only confirmed 2 true interstellar visitors before, the first being Oumuamua back in 2017, the mysterious cigar-shaped rock that flew past without a tail and set off years of wild debate about its true nature. The second interstellar visitor was Borisov, discovered in 2019. It behaved more like a regular comet, glowing tail, icy core, but still carried that rare interstellar passport. And now, we have 3I/Atlas, the third known traveler from beyond our solar system. Just think about that. 3 known objects out of billions of comets and asteroids we've ever tracked. These aren't just discoveries. They're once-in-a-generation cosmic events. When scientists ran the data, they found 3I/Atlas racing through space at nearly 221,000 kilometers per hour. That's about 137,000 miles per hour. At that speed, it could fly from Earth to the Moon in less than 2 hours. Its nucleus, somewhere between half a kilometer and 2 kilometers wide, is small but powerful. A frozen engine blasting out gas and dust to form its glowing coma and tail as it tears through the void. That kind of velocity made one thing crystal clear: this comet wasn't staying. It was just passing through, a cosmic stranger saying a quick hello before vanishing back into interstellar darkness. When it was first spotted, 3I/Atlas was still far out, more than 3 times the Earth's distance from the Sun. Yet, even from that remote region, it was already coming alive. A faint halo of gas and dust shimmered around it, showing that sunlight had begun heating its icy surface and releasing material into space. That early activity sent a shockwave of excitement through the astronomy community. If it was already this active from such a distance, what kind of spectacle would it become as it drew closer to the sun? That's where things stood. Back then, 3I/Atlas was mysterious and full of promise, set to swing near the sun in late October 2025 and then glide past Earth in December, still safely about 170 million miles away. There was never any danger to Earth, but there was a massive scientific opportunity. A chance to study something truly alien, something that didn't originate anywhere near our solar system. Since its first detection, astronomers across the globe have been tracking 3I/Atlas non-stop, and recently, the James Webb Space Telescope delivered its most detailed observations yet. What it revealed stunned researchers. Instead of behaving like a typical comet, 3I/Atlas showed strange, unpredictable chemical patterns. its gases and dust were reacting in ways that didn't match anything known from solar system comets. Webb's instruments detected exotic molecules that hinted at a completely different chemical history, possibly formed around another type of star. To put it simply, this isn't just another icy rock from the edge of space. It's a piece of another world, carrying clues about how planets and comets might form under entirely different conditions. A fragment of the cosmos, now passing right through our neighborhood. One of the first major updates came from the Gemini South Telescope in Chile. By late August, astronomers noticed something striking. 3I/Atlas had changed. Its coma had brightened dramatically, and its tail had stretched into a long, elegant streak. It was no longer just a faint blur in the sky. It now looked like a true comet awakening from deep space. That transformation revealed a lot. The comet was heating up and releasing gas and dust much faster. In short, it was coming to life. But then, things got even stranger. Observers began to spot a faint green glow spreading through the coma. Now, comets sometimes glow green when sunlight excites molecules like diatomic carbon or cyanogen, causing them to fluoresce. But seeing that color appear so far from the sun was unexpected. It hinted that 3I/Atlas might hold an unusually high concentration of these molecules, or that it was releasing them much earlier than usual. Scientists are still cautious about confirming the color, but even the possibility has people buzzing. This comet clearly isn't following the standard rules. There's more. The comet's activity appears uneven. It's releasing far more material on the sun-facing side than on the dark side. That might sound normal, but the imbalance is sharper than usual. This suggests that its nucleus isn't uniform. Maybe one region is richer in volatile ices, or the internal structure allows gas to escape more easily from certain spots. Whatever the cause, 3I/Atlas is putting on a show unlike anything astronomers have seen before, offering a rare front-row look at how an alien comet reacts when the sun's heat begins to awaken it. Since its discovery, 3I/Atlas has gone through a total transformation. A brighter coma, a longer tail, a strange green shimmer, and lopsided activity. But those were just the things we could see from Earth. The real shock came when astronomers aimed the James Webb Space Telescope at it. Ground telescopes can show what the comet looks like. Webb, however, can reveal what it's made of. And that's where the mystery deepened. The James Webb Telescope wasn't built only for galaxies billions of light years away. It's also perfect for studying small, icy visitors right here in our cosmic neighborhood. So when 3I/Atlas drifted into the perfect position, scientists immediately brought Webb into the investigation. On August 6, 2025, Webb's near-infrared spectrograph, NIRSpec, locked onto the comet. That might sound complex, but the concept is simple. Instead of taking pictures, NIRSpec splits the comet's light into its individual wavelengths, much like a prism creating a rainbow. Hidden within that rainbow are chemical fingerprints, signatures left behind by different molecules such as water vapor, carbon dioxide, methane, and more. By reading those light patterns, Webb effectively scans a chemical barcode of the comet, revealing everything that's evaporating off its surface. And it does all of this from millions of miles away. No need to send a probe or collect samples. Webb can identify the ingredients directly from the light they emit. It's a bit like catching the scent of food cooking in another room. You can't see the dish, but your senses tell you what's in it. Webb does the same, but with microscopic precision, detecting elements and molecules invisible to any human eye. Scientists expected to find the usual recipe: plenty of water vapor, a mix of carbon dioxide and carbon monoxide, plus the normal dust and icy grains that make up most comets. But what they actually found next would change everything they thought they knew about these ancient cosmic travelers. That's the usual chemical signature for comets born in our solar system. But 3I/Atlas clearly wasn't following the rules. The data from James Webb stunned even veteran comet researchers. This visitor from another star system turned out to be packed with something rarely seen in such huge amounts. When scientists examined the readings, they noticed something extraordinary. Instead of being dominated by water vapor, the standard ingredient in most comets, 3I/Atlas was spewing out carbon dioxide. And not just a little. The ratio of carbon dioxide to water was nearly 8-to-1. For context, most comets here at home have far more water than CO2, so this completely flips the normal balance. In short, its chemistry is upside down. That discovery raised fascinating questions. Did 3I/Atlas form in a region of its original star system so cold that carbon dioxide froze and built up while water stayed trapped deep inside? Or could the comet's outer shell somehow be sealed, allowing CO2 to escape more easily while water remains locked beneath the surface until it gets closer to the sun? Both ideas make sense, and either one tells us this object holds clues about a world utterly unlike our own. Every comet we've studied so far reveals pieces of our solar system's past, what the swirling disk of gas and dust around the young sun once looked like. But 3I/Atlas isn't from here. Its icy makeup is a frozen record of another solar nursery, a system shaped by different temperatures, different chemistry, maybe even a different kind of star. Studying it is like holding a relic from another world, a physical fragment of a cosmic neighborhood light years away. And the surprises didn't stop with carbon dioxide. Webb also detected water, carbon monoxide, a sulfur-bearing compound known as OCS, plus loads of dust and ice, all mixing together in a strange alien cocktail unlike anything ever observed before. Yes, water is there, but it's not running the show. Imagine expecting a glass full of water and realizing it's mostly soda with just a splash of water mixed in. That's how strange 3I/Atlas really is. This single discovery has forced astronomers to rethink everything they know about comets. If just one interstellar traveler can break all the usual rules, how many other variations might be drifting unseen through the galaxy? It raises a bigger question. How many different ways can planets and comets form around other stars? Every clue suggests the universe is far more diverse and far more chaotic than we ever imagined. But things didn't stop at chemistry. Astronomers decided to take their study one step further. Instead of only examining what 3I/Atlas is made of, they analyzed how light scatters off its dust, a method known as polarimetry. It sounds complex, but the concept is simple. When light bounces off tiny dust particles, it changes in a way that reveals details about their size, shape, and surface texture. Think of it like a handshake. The way light interacts with dust can tell you something about its character. A soft handshake, a firm one. Each tells a different story. And when astronomers shook hands with 3I/Atlas, the result was unlike anything they'd seen before. The comet displayed an extreme negative polarization branch at small angles, meaning the way its dust reflected light didn't match any known pattern from comets in our own solar system. In plain terms, the light coming from 3I/Atlas was behaving weirdly, hinting that even the dust grains coating its surface are built differently, shaped and structured in ways that seem completely foreign to anything formed under our sun. In fact, the effect was stronger than anything ever recorded, dropping below -2% polarization, which is completely off the charts. Why does that matter? Because most comets fall into neat, predictable patterns. Their dust scatters light in familiar ways. But 3I/Atlas shattered that pattern, suggesting that its dust particles are shaped differently, clumped in strange formations, or made from exotic materials we rarely find in our own solar system. Some astronomers think the grains could be darker, coated in complex carbon compounds that absorb more light. Others believe it might be the result of the comet's aging process. As it gets closer to the sun, the heating and reshaping of the coma could alter how light bounces off its surface, making it appear unlike anything ever seen before. And that's what makes this so fascinating. If even the dust behaves differently, it hints that comets from other star systems could have surface properties that are completely alien to ours. It's one thing to find strange chemistry that can be explained by where a comet formed, but when even the dust itself breaks the rules, it forces scientists to reconsider what normal even means for comets. Once again, 3I/Atlas proves it's no ordinary frozen traveler. It acts like a comet, sure, but with its own strange personality. And that uniqueness matters, because every interstellar visitor teaches us something new about the diversity of worlds beyond our own. Our solar system, it turns out, isn't the universal standard. It's just one example among countless others, each with its own quirks, chemistry, and cosmic history. And when you compare all three known interstellar visitors, Oumuamua, Borisov, and now 3I/Atlas, you start to see how wildly different they are. Oumuamua zipped by like a mysterious tumbling shard. Borisov looked more like a traditional comet, but 3I/Atlas? It's rewriting the rulebook entirely. The strangest part about Oumuamua was that it never grew a tail. It didn't behave like a comet at all, more like a solid chunk of rock slicing through space. Then came the mystery of its sudden acceleration as it left the solar system, as if something invisible had given it a gentle push. Scientists debated everything from hidden gas vents to radiation pressure, while some even dared to whisper about artificial origins. Whatever the truth, Oumuamua shattered every expectation. Then, in 2019, came Borisov, far easier to understand. It looked and acted like a traditional comet, a glowing coma, a long trailing tail, and a chemical makeup not too different from what we see in comets born near our sun. The only twist was its birthplace. It wasn't from here. Borisov proved that other star systems likely create comets just like ours, icy fragments flung out into interstellar space. And now, there's 3I/Atlas. At first glance, it fits the comet category perfectly. But look closer, especially through the eyes of the James Webb Space Telescope, and it doesn't quite match either of its predecessors. It's not a bare rock like Oumuamua, and it's not a normal comet like Borisov. It's something in between. Yes, it's a comet, but one with chemistry so bizarre it makes scientists stop and rethink everything. Its overwhelming carbon dioxide dominance and its strange, light-scattering dust set it apart completely. So what does that mean? It tells us the universe's diversity is far greater than we imagined. Between the stars, there's an entire population of objects that defy our categories. Comets, asteroids, hybrids, and things we don't even have names for yet. If the first three visitors are this different, one rocky and mysterious, one familiar and icy, and one chemically alien, it's hard not to wonder, what will the fourth or fifth interstellar visitor look like? Maybe we've only just started to glimpse the endless variety drifting in the dark between worlds. That's what makes these discoveries so thrilling. They're not just random space oddities. Each interstellar visitor is a glimpse into another solar system, a frozen sample from a world we'll never see. Everyone adds a new data point to the growing story of how planets, comets, and star systems form across the galaxy. And the more of them we find, the clearer and stranger that story becomes. But every time one of these cosmic travelers appears, the same question starts flying around. Could it be alien? We saw it with Oumuamua, and sure enough, 3I/Atlas has sparked its own wave of speculation. Some have suggested it might be artificial, or at least worth considering. Even Harvard astrophysicist Avi Loeb has weighed in. He's proposed something called the Loeb scale, a way to rank interstellar objects from 0, definitely natural, to 10, definitely artificial, based on how unusual they seem, their shape, path, size, or possible emissions. According to Loeb, 3I/Atlas earns around a 2 or 3, not impossible but still leaning natural. He points to its large size and its strangely precise orbital path as mild curiosities, though so far no evidence of alien technology like radio signals or engineered structure has turned up. And honestly, it's easy to see why people jump to those theories. An object racing in from another star system, glowing green and spewing out exotic gases. It sounds like something straight from science fiction. But when you strip away the sensationalism and look at the actual data, 3I/Atlas doesn't need an alien explanation to be fascinating. Everything observed so far fits within the boundaries of what a natural comet could do. Just one with chemistry that refuses to follow the usual rules. There's no sign of machinery, no artificial design, no strange maneuvers, only nature showing us once again that reality doesn't need to be engineered to feel otherworldly. Honestly, the natural explanation is the most thrilling one. If just one comet from another star system can be this strange, imagine how many more are out there, each carrying its own chemical fingerprint, its own story from a distant world. It's like receiving postcards from places we'll never visit, snapshots of alien star systems drifting right into our cosmic backyard. You don't need science fiction to make that exciting. The science itself is the story. Speculation may grab headlines, but the real wonder lies in the diversity these objects reveal. We're not looking at proof of aliens. We're looking at proof that the galaxy is wildly diverse, that what forms around one star can be completely different from what forms around another. And that story is still unfolding with every new interstellar visitor. So what's next for 3I/Atlas? The show isn't over. In fact, it's just beginning. Its closest approach to the Sun, known as perihelion, won't happen until late October 2025. By then, it'll be about 1.36 astronomical units from the Sun, a bit farther than Earth, but still close enough for sunlight to crank up the heat and trigger dramatic new activity. That's when things could get really interesting. Will carbon dioxide continue to dominate its outgassing, or will water vapor finally take over as the main driver? That's one of the biggest questions astronomers are eager to answer. After perihelion, the comet will swing outward again, passing near Earth's orbit in December, though still safely distant, nearly twice as far as Earth is from the Sun. There's no threat, but telescopes around the world will be watching closely, hoping to catch every shift and flare. And if we're lucky, some amateur astronomers with good equipment might even spot it. Don't expect a blazing, sky-filling spectacle, but if its activity keeps increasing, 3I/Atlas could become visible through strong telescopes, a faint greenish ghost from another star system, lighting up the edge of our solar neighborhood for one brief visit. What makes this phase so fascinating is that we're tracking a moving, evolving target, a comet that's changing right before our eyes. Right now, its chemistry looks strange because it's still far from the Sun. But as it draws closer and heats up, new ices will begin to sublimate, adding even more layers to the mystery. With the combined power of the James Webb Space Telescope, Hubble, and some of the world's largest ground-based observatories, we're not just watching 3I/Atlas get brighter. We're watching its entire composition transform in real time. Every flicker in brightness, every new outburst, every shift in its tail is a clue to what's hidden beneath its icy surface. And that's what makes this so special. This is a one-time event. 3I/Atlas is on a hyperbolic trajectory, meaning once it swings past the Sun, it's gone forever, vanishing back into interstellar space. We'll never get another chance to study it. That's why scientists are pouring every available resource into observing it now. Every spectrum, every image, every data point matters, because this isn't just about one comet. It's about understanding how alien solar systems form and evolve. Each observation brings us a little closer to uncovering what kind of environments exist beyond our own. Over the next few months, researchers expect a flood of new findings, fresh chemical detections, evolving structures in the tail and coma, and maybe even surprises no one saw coming. And as 3I/Atlas fades back into the dark, it leaves behind something bigger than itself. A reminder that the universe is full of wonders so strange they almost feel impossible, yet they're right there, drifting past us in silence. What makes this next phase so exciting is that we're now tracking a moving target that keeps evolving. Right now, its chemistry looks bizarre because 3I/Atlas is still far from the Sun. But as it gets closer, new types of ice could begin to sublimate, revealing entirely new layers of its story. Thanks to the combined power of JWST, Hubble, and the world's largest ground-based observatories, scientists won't just see the comet getting brighter. They'll be able to measure every change in detail, every tiny fluctuation in its tail, every shift in gas composition, every flare of brightness. All of it is a clue to what this comet is made of and how it formed. And that's what makes this moment so special. It's a once-in-forever opportunity. 3I/Atlas is on a hyperbolic path, meaning once it swings past the Sun, it's gone for good. It will never return. That's why astronomers around the world are racing to capture every spectrum, every image, every particle of data they can before it vanishes back into the dark. Because this isn't just about one comet. It's about what this frozen messenger can teach us about solar systems we'll never visit in person. Over the coming months, we'll likely see new chemical detections, shifts in the tail and coma, and maybe even surprises that nobody saw coming. And as 3I/Atlas drifts back into the endless dark, it reminds us just how mysterious and unpredictable the universe really is, full of things that seem almost impossible, yet completely real. If you enjoyed this breakdown and want to stay updated on every new discovery from the depths of space, make sure to like, subscribe, and share. Your support helps keep these cosmic stories coming. Thanks for watching, and as always, keep looking up.